Hello, Math 442. I told you all to be on the lookout for a little introduction to Chapter 5. Here it is. Chapter 5 is about permutations. First, a quick definition. A permutation of a set A is a function from A to A that is both one-to-one and onto. So in order to talk about a permutation, we need to have an underlying set. Typically, that set is the numbers from 1 to fill in the blank. One more definition. A permutation group of a set A is a set of permutations of A that forms a group under the operation function composition. So when we do multiplication in our group of permutations, that multiplication will be function composition. Alright, so for example, I said we needed to have an underlying set, so let's let A be the set 1, 2, 3, 4, 5. And I'd like to specify a permutation on A. So in order to do that, what I'm going to do down here is I'm going to copy over A. And a permutation from A to A should just be a function going from 1 to A. So maybe I'll draw some arrows indicating what our permutation is going to do. Maybe it'll take 1 to 2. It will take 2 to 3. Sorry, my arrows are lousy. How about 3 to 1? 4 to 5? And 5 to 4. So if I call this function maybe alpha, it looks like alpha takes 1 to 2, so alpha of 1 is equal to 2. Alpha of 2 is equal to 3. Alpha of 3 is equal to 1. Alpha of 4 is equal to 5. And alpha of 5 is equal to 4. Alright, so another way to communicate this permutation alpha is in what I would call block form. So the block form for the permutation alpha would have kind of a block matrix with the numbers that populate the set A, 1 through 5, written on the first row. And then below those I would write alpha of 1, alpha of 2, alpha of 3, alpha of 4, and alpha of 5. So the block form for this permutation would be 1, 2, 3, 4, 5. And then beneath that I would have 2, 3, 1, 5, and 4. So that's a way of representing a permutation alpha. And we could check, by the way, that this function is indeed one-to-one. Nothing has two things being mapped to it, and onto. Everything in the set from 1 to 5 is being mapped to by some element. Alright, so I want to talk about composition of permutations, and in order to do that I need to have some other permutation. So I'm going to create another permutation, say beta. Beta is going to be the permutation that takes, let's define it in block form, 1 to 1, 2 to 4, 3 to 2, 4 to 3, and 5 to 5. So what I'd like to do is I want to compose alpha with beta. Well, one thing to make sure we remember function composition is a right-to-left operation. So essentially what we want to do is we want to do beta and then afterwards do alpha. So if I want to know what alpha of beta does to the element 1, Well, first I would figure out what beta does to 1, and then afterwards I would alpha that. So beta of 1 is 1. And alpha of 1 is equal to 2. So this means that when we come up with the block form for alpha beta, beneath 1, I should have 2. Now what should I have beneath 2 and 3 and so on? Well, I could continue this process. To find out what should go below 2, I could do alpha beta of 2, which is alpha of beta of 2, which is alpha of, well, looking back, it looked like beta of 2 is 4, and alpha of 4 was 5, so I guess 2 should be going to 5. So an easier way to do this would be to write the two block forms next to each other, or one above each other even, and then figure out what's happening as the composition goes on. So I'm going to do that on the next slide. So alpha was this guy, and then beta was this other guy. So if I want to do alpha beta, well, like I said, I want to go from right to left. So first I would look for where 1 goes on the left, and then I would feed it. 1 goes to 1, and then 1 goes to 2. So I see that 1 goes to 2 in the composition, and then 2 goes to 4, and 4 would go to 5 in the one on the left. Now 3 goes to 2 on the right, and 2 goes to 3. So in the composition, 3 would go to 3. Now 4, I'm going to stop drawing line segments because this is getting clumsy. 4 goes to 3 on the right, and then 3 on the left is sent to 1. So 4 would go to 1. Finally on the right, 5 goes to 5, and then on the left, 5 goes to 4. So I guess 5 would need to go to 4. Now I could perform this composition in the opposite order. And already my head's kind of spinning because I really would like to have these things written down without a bunch of lines on them. So I'm actually going to go to the next slide for this, sorry. So if I'm trying to figure out what here beta alpha is, I guess I want to have my beta on the left. So beta was and my alpha on the right. All right, so let's see. The composition would work from right to left. So we would have, let's see, on the right, 1 goes to 2, and then 2 goes to 4. On the right, 2 goes to 3, and then 3 goes to 2. On the right, 3 goes to 1, and then 1 goes to 1. On the right, 4 goes to 5, and then 5 goes to 5. And on the right, 5 goes to 4, and then 4 goes to 3. So this is the composition beta alpha. So you'll notice immediately that, that beta alpha is not the same thing as alpha beta. Alpha beta had block form. So permutation groups are generally very not abelian. There's not a lot of commuting that goes on in these things, which makes it interesting to find things like their center. So one more thing before I let you all off the hook. I wanted to talk to you about another way to represent these things instead of block form or specifying where their elements go. And that's what's called cycle form. So if I recall my block form for alpha, then I can think of this as being split into a couple of different cycles. So if I start with the number 1 and ask where it maps, well, it maps to the number 2. And then 2 in turn maps to the number 3. And 3 maps back to 1, closing a cycle which would continue infinitely. 1 to 2 to 3 to 1 to 2 to 3. 4 maps to 5. And 5 maps to 4, closing a cycle. The way that I would express this then in what's called cycle notation is just kind of a listing of the cycles one at a time. So 1 goes to 2, goes to 3, and I close the cycle. So within parentheses I have cycles. And then 4 goes to 5. We could do the same thing for beta. Beta was 1 goes to 1, 2 goes to 4, 3 goes to 2, 4 goes to 3, 5 goes to 5. So here, 1 is kind of its own cycle. 2 maps to 4, maps to 3, which maps back to 2, and then 5 is also its own little cycle. So I could write this as 1, 2, 4, 3, 5, and oftentimes people will omit 1 cycles and write this as simply 2, 4, 3. And oftentimes people will actually omit commas and simply write this as 2, 4, 3. Okay, everybody, thank you so much for taking the time to sit through that. Maybe we'll start off next class with a couple of computations to get you comfortable with doing this on your own. I'll see you all on Tuesday. Thank you.